In this chapter, we'll be going over linear equations and rational equations. So starting with linear equations, a linear equation is in one variable is going to be an equation that can be written in the form ax plus b equals 0. So a and b here are just real numbers. Linear equations are first-degree polynomial equations. What this means is that the variable x just has a 1 as the exponent. So solving an equation is going to be determining all of the values of x that result in a true statement, and we can call these the solutions or the roots for the equation. And the set of all solutions is going to be called the equation's solution set. Okay, so let's do an example here. So let's show that -3 is a solution for 4x plus 12 equals 0. So this means we need to show that when we plug in -3 into x and simplify, we get a true statement. So let's plug in -3 to x here. And we're going to show that the left-hand side of the equation equals 0. So simplifying this, we get -12 plus 12 equals 0. And -12 plus 12 is 0. So we get 0 equals 0, which is a true statement. So that means -3 is a solution. Okay, so when we're solving linear equations, what we're going to have to do is we're trying to isolate x. So we need to generate equivalent equations until we have x solved for. And we can do this by adding, subtracting, multiplying, or dividing the same number to each side. So here are kind of the generic steps for solving a linear equation. The first step is going to be simplify the expression on each side of the equation separately. So we're going to do it on the left-hand side and the right-hand side. This essentially is going to consist of distributing and combining like terms. And then what we're going to do is we're going to collect all variable terms on one side of the equation and constant terms on the other side of the equation. And we're going to isolate the variable and solve it. And we have to remember that we can always check our solution by plugging it back in the original equation and making sure we get a true statement. Okay, so let's do a bunch of examples here. So starting off with an easier example, 5x equals 45. So this is saying 5 times what equals 45. So we have to isolate the x. So we have to get rid of this 5 somehow. So to do that, we have to use the opposite operation. Than what's being done to it now. It's being multiplied on the x. So to get rid of it, we have to divide it. So if we divide it to one side, we have to do it to the other side. So 5 divided by 5 equals 1, so they cancel. So that gives us 1x, which is what we want, equals 45 over 5, which is 9. So let's make sure that this is actually a solution, so we're going to check it. So when we check it, we're going to start with the original, and we're going to plug in 9 into x. So 5 times 9 equals 45, and I'll put a question mark because we're checking it. So 5 times 9 is 45. We get 45 equals 45, which is true. So this obviously is the solution. Okay, so doing another one here, we have x plus 3 equals 17. So to isolate the x, we have to somehow get rid of this plus 3. So we have to do the opposite operation to get rid of it, which is we have to subtract 3. So we have to do that to both sides. 3 minus 3 is 0, so the left-hand side gives us x. 17 minus 3 is 14, so we get x equals 14. And once again, let's just double check this. So check. We have plugging in 14 into x, so it becomes 14 plus 3 equals 17. Question mark, we're checking it. 14 plus 3 is 17. So we are good, and that is our answer. Next one, we have 4x plus 5 equals 29. So this time we have to get rid of this plus 5 and this 4 to isolate the x. So when we're doing this, the first step should always be get rid of the number that's being added or subtracted. So that's going to be minus 5 on both sides to cancel that 5. So it's going to be 4x equals 29 minus 5, so 24. And now to get rid of that 4, opposite operation for multiplication, we have to divide it. So we're left with x on the left. 24 divided by 4, we get 6. So I'll leave, for time's sake, I'll leave the rest for you to check. But we can plug in 6 into the original and verify that that is our solution. Okay, for the next one, we have 5x minus 2x minus 10 equals 35. So first, for this one, what we have to do is we have to simplify the left-hand side by distributing first that negative. And when we distribute that negative, we're going to get 5x minus 2x plus 10 equals 35. And now we have to combine like terms on the left. 5x minus 2x, we get 3x plus 10 equals 35. And now we can go ahead and isolate that x. So we have to get rid of the number that's being added or subtracted first, which is the 10. So the opposite operation, we have to subtract it. So it's going to be 3x equals 35 minus 10, so 25. And now we just have to divide both sides by 3. And we get x equals 25 thirds. Okay, so a little messy, but that's okay. For the next one, we have 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2. So we have to distribute the 2 on the left. So we have to simplify both sides of the equation separately here. So distributing the 2, we get 2x minus 6 minus 17. And on the right, we have to distribute this negative 3. So we're going to get 13 minus 3x minus 6. And now we have to combine like terms. So on the left, we have negative 6 minus 17. That gives us 2x minus 23. On the right, we have 13 minus 6, which is going to give us 7. So that's 7 minus 3x. And now we need to get all the variables on one side, constants on the other side. So I'm going to get the variables on the left. So to do that, we have to add 3x to the left-hand side. We added it because it was being subtracted on the right, so opposite operation. So it cancels over here. 2x plus 3x is 5x. So that's 5x minus 23 equals 7. And now we have to get rid of this negative 23. Opposite operation to the other side, we have to add it. So it cancels on the left. And we get 5x equals 7 plus 23, which is 30. And lastly, we divide by 5 on both sides. And we get x equals 30 divided by 5, which is 6. Okay, so definitely make sure that these are correct by plugging them back in the original and making sure they are equivalent on both sides of the equation. Okay, let's do a couple more here. Or one more, and then we'll get to fractions. So we have 4 times 2x plus 1 equals 29 plus 3 times 2x minus 5. So first, combine like terms by distributing first on the left. And we get 4 times 2x plus 1 becomes 8x plus 4. On the right-hand side, we have to distribute the 3. And we get 29 plus 6x minus 15. Combine like terms on the right. The left I'm leaving as is. 29 minus 15, we get 14 plus 6x. And let's get the variables on the left side again. So we could get them on the right or left, it doesn't really matter, but let's just get them on the left. So we have to get this 6x over here on the left, opposite operation, so we have to subtract it because it was being added. So that'll cancel it. We get 8x minus 6x is 2x plus 4 equals 14. Now we have to get rid of that 4 on the left by subtracting it. and we get 2x equals 14 minus 4, so 2x equals 10. And lastly, we just have to divide by 2. So we get x equals 10 over 2, and we get x equals 5. Okay, so let's make these a little more difficult here. So let's solve these linear equations that have fractions in them. So the easiest way to solve linear equations involving fractions is going to be multiply both sides of the equation by the LCD of all fractions in the whole entire equation. We do this because it's going to cancel off every denominator, giving us integers to work with rather than fractions. Okay, so for example, we have this first one, 2/3 x minus 1/2 x equals negative 1/6 x minus 2. Okay, so first we have to determine what our least common denominator is. So we have a 3, a 2, and a 6. The least common multiple of a 3, 2, and 6 is a 6. So we're going to multiply everything by 6. So the reason why we can do that is because we're doing it to both sides of the equation, so we are not changing anything. So when we're multiplying by 6 here, it's going to be 6 being multiplied to every single term. So it's going to be 6 times 2/3 x minus 6 times 1/2 x equals 6 times negative 1/6 x minus 6 times 2. So every term gets multiplied by 6, and then we just simplify them individually. So 6 times 2/3 is going to give us 4. So that's 4x. And the way you're going to want to do this for these is use that 6 and try to simplify it using the denominator. 6 divided by 3 is 2. 2 times this 2 is 4. For the next one, we have 6 times 1/2. That's probably obvious. That's 3. So negative 3x. And for the right-hand side of the equation, 6 times negative 1/6. That's going to be negative 1. So negative x minus 6 times 2, so minus 12. Okay, so now we just generated an equivalent equation with no fractions, so this is a lot easier. So simplify that left-hand side. We get 4x minus 3x is 1x, so just x, equals negative x minus 12. So let's get the variables on the left. So we have to add x to the left, and we get x plus x, which is 2x, equals negative 12. And lastly here, we just have to divide both sides by 2 to cancel that 2 to isolate the x. We get x equals negative 12 over 2. We get x equals negative 6. Okay, so let's do a couple more with fractions. We have x minus 3 over 4 equals 5 over 14 minus x plus 5 over 7. So it looks a little bit different this time because we have binomials here in the numerator divided by our number. So let's look at this LCD here. So the least common denominator is going to be the least common multiple of 4, 14, and 7. The least common multiple of those three numbers is going to be 28. So we're going to multiply everything by 28. So that's going to end up being 28 multiplied to all three of these terms. So 28 times x minus 3 over 4 equals 28 times 5 over 14 minus 28 times x plus 5 over 7. Okay, so don't distribute that 28. What we're going to do is use it to simplify with the denominator. 28 divided by 4, and then we're going to do 28 divided by 14 and 28 divided by 7. So starting with the first one, 28 divided by 4 is 7. So this is 7 times x minus 3. 28 divided by 14 is 2, so this is going to be 2 times 5. 28 divided by 7 is 4, so minus 4 times x plus 5. So always do it that way when you're doing these types of problems. The number out front will simplify with that denominator, and then we won't have any more fractions. So now we can go ahead and solve the resulting equation here. Distribute the 7, we get 7x minus 21. 2 times 5 is 10. Distribute the negative 4 minus 4x minus 20. Let's combine like terms on the right. So 7x minus 21, 10 minus 20, we get negative 4x minus 10. And let's get the variables on the left. So let's add 4x to the left-hand side to cancel it on the right. And in one step here, if you're comfortable with it, you can do this in one step. Let's get the constants on the right by adding 21. So we get 7x plus 4x is 11x. Negative 10 plus 21 is 11. And now all we have to do is divide both sides by 11 to isolate the x. We get x equals 11 over 11, which is just 1. So x equals 1 is our answer here. Okay, so we have one more fraction one. So we have x plus 3 over 6 minus x plus 1 equals 3 over 8 minus x minus 2 over 12. So let's take a look at this LCD. So the LCD here is going to be the least common multiple of 12, 8, and 6. The least common multiple of these three numbers looks like it's going to be 24. Okay, so we're going to multiply everything by 24. And we have four different main terms here. We have this term, this term, this term, and this term. So we're going to multiply all of those by 24. So 24 times x plus 3 over 6 minus 24 times x plus 1 equals 24 times 3 over 8 minus 24 times x minus 2 over 12. Okay, so all four of those terms got multiplied by 24, and now let's use it to simplify them. 24 over 6. So 24 divided by 6 is 4. So 4 times x plus 3. And the second term, I'm just going to leave it as is because there's no denominator other than 1. 24 divided by 8 gives us 3. So that's 3 times 3 minus 24 over 12 is 2. So minus 2 times x minus 2. So there we go. There's an equivalent equation with no more fractions. So let's go ahead and solve this. So distribute the 4 and negative 24 on the left. We get 4x plus 12 minus 24x minus 24. On the right, we get 3 times 3 is 9. Distribute the negative 2 minus 2x plus 4. And we're going to simplify each side separately, combine like terms. So you get 4 minus 24x, that's negative 20x. So negative 20x, and then 12 minus 24 is negative 12. And on the right-hand side of the equation, 9 plus 4, we get 13 minus 2x. And let's get the variables on the left, I guess. Again, it doesn't matter. So I'm going to add 2x. And at the same time, let's get the constants on the right. So we're going to add 12 to the right. So we're going to get negative 20x plus 2x. Negative 20 plus 2 is negative 18x. And then 13 plus 12, we get 25. And the last step here, we're going to divide by negative 18 to cancel it on the left. And it doesn't look like this really simplifies for us, so we get x equals negative 25 over 18. So now moving on to rational equations. A rational equation is going to be an equation that has one or more rational expressions. And remember what this means. This is when a fraction has a polynomial in the numerator and denominator. So essentially now we're going to have variables in the denominator. So something like 5 over 7x minus 2 over x minus 3 equals 1/7. This would be a rational equation. We have an equation containing rational expressions. So to solve these ones, it's going to be similar to what we did with solving linear equations with fractions. We're going to have to multiply both sides of the equation by the least common denominator. So essentially the LCD of these rational expressions is going to be a polynomial consisting of all of the factors of the denominators, but you don't have to repeat them if they already occurred in that LCD. And we have to exclude any x values that make the denominator equal 0 because we can't divide by 0. Okay, so let's see a couple examples here. So this first one, we have 1 over x equals 1/5 plus 3 over 2x. So first we have to find the LCD. And the LCD here, it's good to start with the coefficient. So the LCD of 2 and 5, the least common multiple of 2 and 5 is going to be 10. And then for the variables, we only have an x and an x. So that's just going to be another x. So it's going to be the LCD is 10x. So we're going to multiply this whole thing by 10x. And before we even start with the problem, we have to exclude the values that make the denominator equal 0. So we have to exclude x equals 0, because throwing in an x equals 0 into here will make both of these denominators 0, so we exclude it from the domain. Okay, so multiplying everything by 10x here, we're going to get 10x times 1 over x equals 10x times 1 over 5 plus 10x times 3 over 2x. Okay, so once again, let's use this 10x to cancel those denominators. All the denominators should be completely gone. So it's going to be 10x divided by x. The x's cancel. We're left with 10 times 1, which is just 10. So next we have 10x over 5. 10 divided by 5 is 2. So 2x times 1 is just 2x. And for the last term here, we have 10x over 2x. The x's cancel. 10 divided by 2 is 5. 5 times 3 is 15. So now we have this nice linear equation that we can solve. So solving this, we just have to isolate the x. So let's subtract 15 on both sides. Keep the variable on the right. 10 minus 15, we get negative 5 equals 2x. Divide both sides by 2. And we get x equals negative 5 over 2. Okay, and then put a little reminder in that x cannot equal 0. Okay, so let's do another one. So we have 5 over 2x equals 17 over 18 minus 1 over 3x. So let's figure out this LCD. So looking at the coefficients in the denominator first, we have a 2, 18, and a 3. The least common multiple of those is going to be 18. And once again, we have for the variables an x and an x. So that is going to give us 18x for the least common denominator. And we're going to multiply everything by 18x. So while we're here too, before we forget, let's make sure we exclude the necessary x values. So the value that would make these denominators 0 is if x were 0. So once again, let's exclude 0 from that domain. Okay, so let's go ahead and multiply every term by 18x. So that's 18x times 5 over 2x equals 18x times 17 over 18 minus 18x times 1 over 3x. And let's simplify. So 18x over 2x. The x's cancel. We're just left with 18 over 2, which is 9. So I'll do 9 times 5 equals 18x over 18. The 18s cancel, we're just left with x. So that's 17x. And lastly, we have 18x over 3x. The x's cancel. 18 over 3, we get 6. So 6 times 1, so just 6. Okay, so let's simplify that a little bit. We have 45 equals 17x minus 6. So we need to get the x by itself, so let's add 6 to both sides here. 45 plus 6, we get 51. 51 equals 17x. Divide both sides by 17, and we get 51 over 17 is 3. So x equals 3, and just a reminder, x is not allowed to equal 0. Okay, so let's do a couple more here. We have x over x minus 3 equals 3 over x minus 3 plus 9. So the LCD is going to be x minus 3. So it's x minus 3 is that whole LCD. That's the only thing in the denominator other than 1. We have an x minus 3 here, an x minus 3 here, and it's 9 over 1. So the LCD is just x minus 3. Okay, so we're going to multiply everything by x minus 3. Make sure it's in parentheses. And while we're up here, the only value for x that would make these denominators 0 is if x were equal to 3. So x cannot equal 3. Okay, so multiplying everything by x minus 3, we get x minus 3 times x over x minus 3 equals x minus 3 times 3 over x minus 3 plus x minus 3 times 9, or just 9 times x minus 3. Okay, so now we can start canceling here. We have x minus 3 divided by x minus 3. That's going to cancel to 1. So we're just left with the numerator, which is x. X minus 3 divided by x minus 3 once again. They cancel. So we're just left with that numerator, which was 3, plus 9 times x minus 3. Okay, so now we have a linear equation again. Let's go ahead and solve this for x. We get x equals 3 plus distribute the 9, 9x minus 27. And combining like terms, that's going to give us 3 minus 27 is negative 24 plus 9x. So let's add, or rather subtract. Let's get the variables on the left. Let's subtract 9x on both sides. So we're going to get x minus 9x is negative 8x equals negative 24. Divide both sides by negative 8. Negative 24 divided by negative 8. And we get x equals 3. So if we remember to what we had before all the way up here on the right, we said x cannot equal 3 because that makes the original denominator 0. So since we got an answer of x equals 3, that actually means there's no solutions because that value is out of this domain. So since our answer cannot be 3, that means there are no solutions here. So this is an example of an equation that has no solutions. Okay, so let's do one more. So we have 3 over x plus 6 plus 1 over x minus 2 equals 4 over 3x squared plus 12x minus 36. So before we find the LCD here, we have to factor. The other ones were already factored. This one is not factored, so let's factor it. The first denominator here is good. We don't have to do anything. It's already prime. Same thing with the second one. We can't do anything with it. This third one, though, on the right side of the equation, we can factor out a 3. If we factor out a 3, we're left with x squared plus 4x minus 12. And we can actually factor this again. So leaving these first ones the same, factoring that last denominator, that 3 is still going to be there. Two numbers that multiply to negative 12, that add to positive 4. That's going to be x plus 6 times x minus 2. Okay, so now that these denominators are completely factored. Now let's take a look at our LCD. So for our LCD here, it's going to be essentially the product of every denominator, except for we don't have to write the same factor in more than once if it already appeared. So let's take a look at this right here, this big denominator. So our LCD so far would be 3 times x plus 6 times x minus 2. Since these other denominators, x plus 6 and x minus 2, are already included there, we don't have to adjust that LCD. That is our LCD. So our least common denominator is 3 times x plus 6 times x minus 2. So what we have to do is multiply that by everything. So let me move that up a little bit. Okay, so let's multiply this whole equation by that LCD, and let's see what happens here. So for this first term, so actually before I do that, let's exclude the values that make the denominator 0. So it helps to look at the LCD for this. The values that make this equal to 0 are going to be -6 and +2, right? If we plugged those in there, it would make that whole term equal to 0. Okay, so let's multiply that least common denominator by every term here. So it's going to be 3 times x plus 6 times x minus 2 times that first term, 3 over x plus 6, and then plus that least common denominator times the second term, 1 over x minus 2. Let me move that over. And lastly, the right-hand side of the equation, 3 times x plus 6 times x minus 2 times 4 over 3 times x plus 6 times x minus 2. So you don't always have to write this step. If you can multiply it in your head and see what's left over, that would be fine. Okay, so let's take it one term at a time here. So for the first term, we have this whole thing and that denominator. Let's use it to cancel it off. So the x plus 6's cancel here. So I'll actually cancel them. So we're left with 3 times x minus 2 times 3. So I'm just going to write that as 3 times 3 is 9 times the x minus 2. So next we have this whole thing divided by x minus 2. The x minus 2's cancel, so we're just left with 3 times x plus 6 times 1. And now for the right-hand side of the equation, we have this whole thing divided by itself. So everything actually cancels here. So all we're left with is 4. Okay, so let's go ahead and solve this resulting equation. So distribute the 9, 9x minus 18, distribute the 3, 3x plus 18 equals 4. So on the left-hand side of the equation, the 18's actually cancel, and we get 9x plus 3x is 12x. So 12x equals 4. And we have to divide both sides by 12. 4 divided by 12 simplifies to 1 over 3. So we double check, we make sure that 1 over 3 was not part of the domain that gets excluded, and it wasn't. We said x cannot equal -2, -6 or +2. So that is our answer. Okay, so that is it so far for linear equations and rational equations and how to solve them. So there are a couple different types of equations here, and we kind of touched on it in the rational equation part. So the 3 types of equations are going to be called the identity, conditional, and inconsistent. So for the identity equation, this is an equation that's true for all real numbers. So for example, something like x plus 3 equals x plus 2 plus 1. So if we tried to solve this for x, we would get x plus 3 equals x plus 3, combining like terms on the right, And if we try to subtract x and subtract 3 on both sides, we would get 0 equals 0. So this is because clearly both sides of the equation are exactly the same. So no matter what we plugged in for x, we would always get a true statement. So what this means for an identity equation is that there's infinitely many solutions. If we can plug in any value for x and it's always going to be true, then there's infinitely many solutions. So let's take a look at the next one. The next one is a conditional equation. A conditional equation is an equation that's true for at least one real number, but not all real numbers. So something like 2x plus 3 equals 17. If we solve this for x, we would subtract 3 and get 2x equals 14. Divide by 2, we would get x equals 7. So this is only true for x equals 7. Okay, so that's how most of our examples end up being. They end up being conditional. They're true on, in this case, one condition. Last one, inconsistent equation. For an inconsistent equation, this is an equation that is never true. So for example, if we had x equals x plus 7, if we subtract x on both sides, let's say we wanted to get it to the left, subtract this x, they actually cancel on both sides and we're left with 0 equals 7. So this is obviously not a true statement. 0 does not equal 7. So the variables canceled. We got a false statement. That means it is an inconsistent equation. So that means there's actually no solutions. Okay, so there'd be no solutions for this equation, and we saw that a couple examples ago with the rational equations, and I put a little note here at the bottom of the page, just kind of summing up the difference between identity and inconsistent. Okay, so let's do one more, a couple examples here to determine whether or not these equations are identity, conditional, or inconsistent equations. So we have 2 times x plus 1 equals 2x plus 3. So if we went to solve this, we would distribute the 2. So 2x plus 2 equals 2x plus 3. And if we try to get let's say we try to get the variables on the left, we would subtract 2x. We would recognize that the variables actually cancel and we're left with 2 equals 3. We could try to subtract 2 on both sides or subtract 3 on both sides. No matter what you do to this, it is always going to be not equal to each other. So this will be an example of an inconsistent equation. So that means for this one, there are no solutions. Okay, and let's do one more here. We have 4x plus 6 equals 6 times x plus 1 minus 2x. So trying to solve this, the left-hand side is already simplified. On the right-hand side, we have to distribute the 6. We get 6x plus 6 minus 2x. So on the right-hand side, we have to combine like terms. 6x minus 2x, we get 4x. So it's probably pretty obvious right here that both sides are exactly the same. So this is going to be an identity equation. Let's just go ahead and subtract 4x just so we can see the variables cancel if you didn't notice it already. And we would be left with 6 equals 6. Once again, we could subtract 6 on both sides and get 0 equals 0. But this is enough to recognize what kind of equation it is. So this is an identity equation, and that means there's infinitely many solutions. So no matter what value of x we plugged in, this will always be true, so infinitely many solutions. Okay, so that is it for this chapter.